In problem number 2, we're asked what volume will 2 moles of nitrogen occupy at 720 torr and 20 degrees Celsius. So let's start with just making our list of variables. We're being asked what volume, so that means we're looking for V. Will 2 moles of nitrogen, so that would be our N, occupy at 720 torr. Torr indicates that's our pressure. And 20 degrees C, which is our temperature. Now, our ideal gas law is PV equals nRT. Now, if you look here, very important, the pressure must be in atmospheres and the temperature must be in Kelvin. So we're used to having to change our temperature to Kelvin by now. That's very easy. We simply add 273 to our temperature in Celsius. So 20 plus 273 gives us our temperature of 293 Kelvin. But what we're not used to having to change is the pressure. Notice the pressure we've been given is in torr, and the pressure we need is atmospheres. So to convert torrs to atmospheres, we just need to set up a conversion factor. We know, or at least we should know by now, that 760 torr is equal to 1 atmosphere. And so, because we know that, when we set this up, now our torrs cancel out, and so to get our answer in atmospheres, we just need to do a simple division, 720 divided by 760. And if we do that math, we get a value of 0.95 atmospheres for our pressure. So an extra step here, very important, because if you don't do that step, you're not going to be able to solve the problem and get the right answer because your units are going to be all messed up. So now that all of our variables are correct and in the correct units, now we can just solve our equation for V. Remember that if our equation is PV equals nRT and we want to solve for V, we want V by itself. So in this case, P and V are attached by multiplication, so we do the opposite, which is divide. And so our new equation that we're going to use to solve is V equals nRT over P. And now we just need to plug and chug. So our N, we said, was 2 moles. Our R is the universal gas constant, which is 0.0821 liter atmospheres per mole Kelvin. And our temperature was 293 K. Now all of that is going to be divided by our pressure, and our pressure was 0.95 atm. And now we just need to show our units canceling out. Our atms are going to go away. Our moles are going to go away. And our kelvins are going to go away, leaving us just with liters, which is good because that's what we're solving for. We're solving for volume. So if we take our calculator and we do 2.0 times 0.0821 times 293, all divided by 0.95, you should get a value of 50.6 liters, or if you want to round that, it would be 51 liters. And that is your final answer.